Hi, I'm Haoyang. Today, I'll be introducing my I5P project on generating Singaporean accented speech from text using zero-shot TTS frameworks. Before introducing this project, I would like to express my greatest gratitude to my project supervisor, Prof. Chung Eun-seung, for his support and guidance throughout the entire project. TTS is an assistive technology that generates speech from text. It has many practical applications, such as being used in virtual assistants, such as Google Virtual Assistant and Siri. It is also used in chatbots, and TTS is also a useful technology to help people with disabilities, such as people who suffer from visual impairments or loss of voice. Zero-shot TTS differs from traditional TTS in that it requires an additional input, which is a few seconds of a speech recording from a speaker, and this speaker can be a speaker that is not seen during the training stage of the TTS. By taking in this extra input, zero-shot TTS can generate new speech using the same speaker's voice. Currently, there is lack of development on zero-shot TTS that can generate high-quality speech in Singaporean accent. One reason is because the demand for Singaporean accented TTS is relatively low in the global market as compared to TTS of other accents. And there is not enough local effort in Singapore to develop such TTS system at the moment. Even though there are many zero-shot TTS systems trained on other speech accents, these TTS systems are unable to adapt to the accent of Singaporean speakers during inference. This is because Singaporean accent is a highly unique accent with distinct acoustic patterns, and zero-shot TTS systems often cannot adapt to a highly unique accent that has never been seen before during the training stage. The objective of this project is therefore to develop a zero-shot TTS system that can generate high-quality English speech in Singaporean accent. We want the TTS to be zero-shot because zero-shot TTS is more powerful than traditional TTS, with its ability to instantly adapt to voice of speakers that are unseen during training. This brings about additional benefits over traditional TTS systems. These benefits include creating more personalized and engaging voice experience for users, as well as acting as a data augmentation tool for other machine learning tasks such as automatic speech recognition, which sometimes require huge amount of speech data from many different speakers in order to learn a good model. We also want the TTS to be in Singaporean accent because people usually find it more natural to communicate with others who speak in the same accent. Therefore, a Singaporean accented TTS can promote Singaporean users' engagement with the TTS system. Also, as people may not understand the speech spoken by an unfamiliar accent, we also hope that a Singaporean accented TTS will increase Singaporeans' accessibility to TTS services. In this project, we use a state-of-the-art TTS architecture based on SC-Glow TTS and Haoyang. In the architecture, SC-Glow TTS first takes in linguistic information from text and acoustic information from a reference speaker's speech recording to generate an intermediate acoustic feature named male spectrogram. A vocoder named Haoyang is then used to convert the male spectrogram into synthesized speech in the same voice as the reference speaker. We use this architecture because it is not autoregressive unlike many other TTS systems, and being autoregressive means that the TTS is fast during inference and is able to perform more robustly when the input text sequence is long. Also, this TTS framework demonstrates its ability to generate speech with high quality based on results from research papers. We apply transfer learning by first acquiring pre-trained SC-Glow TTS and Haoyang models from open source repos. These models are trained on general English accents such as British or American English, and the model acts as the starting point of our training. When compared to training to a new model from scratch, training directly on existing well-trained TTS model can drastically reduce the training time, as well as enabling the TTS to capture richer vocabulary and speaker variety. We then did domain adaptation on the pre-trained TTS model by fine-tuning them on a Singaporean accented dataset named National Speech Corpus. This allows the model to pick up Singaporean accent and enhance the pronunciation of local names. To improve the quality of the TTS, we trained a single-gender TTS by filtering out all the male speakers from the dataset and then selected 7 female speakers with high speech quality among all the female speakers in the dataset. After fine-tuning, We evaluated the speech quality of our TTS model using mean opinion score. The result shows that our fine-tuned TTS model achieved a decent MOS of 4.14, which significantly outperforms the pre-trained TTS model before the fine-tuning. We also evaluated the speaker similarity between the TTS-generated audios and the ground truth audios using cosine similarity. The result shows that the fine-tuned TTS achieved a high cosine similarity of 0.933, which means the TTS is able to mimic the voice of a target speaker quite accurately. Here are some demos of the TTS-generated audios for you to hear, along with the corresponding ground truth speech recording for your reference. Note that both the text transcription and speaker's voice are unseen by the TTS during training.
Number sequence is S6149375P and date of birth is 1st of March 2015.
Number sequence is S6149375P and date of birth is 1st of March 2015.
What are the landmarks near Goodwood Hill?
What are the landmarks near Goodwood Hill?
Thank you.